Hi, let's look at at number 10 on the FCA number 10 review. We're looking for trying to find the area of a regular pentagon that has a radius length of 15 units. All right, so remember, one of the ways we can find the area of a regular polygon is using the formula 1/2 times the apothem times the perimeter of the polygon. The apothem, remember, is a perpendicular that goes from the side of the polygon to the center of the polygon. And in this case, we only have one measurement. Well, first of all, notice that this apothem, when it goes to the center with it meeting the radius at the same point, we form a right triangle. Okay, and we have only one side measurement. Okay, so we've learned two ways to find unknown side lengths for right triangles. One using the Pythagorean theorem, but you need 2 out of 3 values, and then secondly, we can use trigonometric ratios with a side length and an angle measurement. And that's what we're going to have to do in this case because we only have one angle or one side measurement. We're going to have to use trig. So that means we're going to need to get some angle measurements. So first we need to recognize that the 2 radius, the measure of the central angle is formed by 2 radius. And so we have to recognize that for a pentagon, the measure of the central angle is 72 degrees, 360 degrees divided by 5. 5 sides, 5 central angles. If we had 6 sides, we'd have 6 central angles. If we had 8 sides, we'd have 8 central angles. So we got a total of 360 degrees. 360 divided by 5, this central angle is 72 degrees, and then half of 72 is 36. This apothem cuts this vertex angle, this central angle, in half. Okay, because remember these radius, they're congruent, so we've got an isosceles triangle. And when you construct a perpendicular from the base of an isosceles to its vertex, you have, remember, an angle bisector, a perpendicular bisector, an altitude, a median, and so forth. Okay, so back to what we're doing. We're trying to find, we need to find some measurements other than, we need the apothem length and we need the perimeter. Okay, so we're going to have to use some trig to get those. Notice if, since this is a perpendicular, this is a perpendicular bisector. So if I can get this segment here, what I'm calling x, I can double it and get the side length, and then multiply by 5 to get the perimeter. And then I can get the apothem directly. Okay? And again, we're going to have to use trig ratios. So let's start with finding x. Okay? From this 36-degree angle, I have the opposite leg. I want the opposite leg, and I have the hypotenuse. Okay, so from the 36-degree angle, I want opposite, and I have hypotenuse. That's sine. So I'm going to use the sine ratio to solve for x. So the sine of 36 has to equal x over 15. Okay, and then I want to get x by itself, so I multiply both sides by 15, and I have 15 times sine 36 equals x. And when I use my calculator, I get x is approximately 8.82. Okay, so I can represent the x either way, 15 sine 36 or 8.82. If I keep it as 15 sine 36, I'll maintain a more exact value of the length of x. Okay, so then if I take x and I double it, then I have s, a side length, which is approximately 17.63. So I can get the perimeter now. 17.63 times 5 gives me approximately 88.17. Or 2 times 15 sine 36 again represents a side length, and I've got 5 of those. So I can also represent the perimeter as 5 times 2, which is 10 times 15, which is 150. I can also represent 150 sine 36. All right, so we've got the perimeter. Now we need the apothem. Again, from the 36-degree angle, I want the apothem. That's a leg that is adjacent to this 36-degree angle. And then I have the hypotenuse. So the cosine of 36 has to equal adjacent over hypotenuse, or a over 15. Multiply by 15 on both sides to get a by itself. And a, the apothem, can be represented as 15 cosine 36, or approximately 12.14. So using my trig ratio values as my apothem and my perimeter, I get approximately 534.97. If I use my estimates, I get approximately 535.19. Okay, so apothem and perimeter. Apothem, well, this right here is the perimeter, and 12.14 is the apothem. All right, so I reverse those. So that's an example of finding the area of a regular polygon.